Alright, so today we are going to be starting in chapter 5 and we're going to be looking at differential equations. So remember that through our integral units we have looked at some differential equations. We're just going to get a little bit more into one, slope fields, which are another representation of differential equations, and then two, some additional methods to solve differential equations. So just as a reminder, remember that a differential equation is an equation that contains a derivative. Now, it is important to remember that our solutions are lines, okay? Because remember, we're looking at things like dy, dx equals stuff with x's in it. So then when we take the antiderivative of that to solve, we end up with y equals stuff with x's in it. And so we're looking at different types of lines. So remember, a particular solution is one equation that satisfies the original derivative requirements. We're going to look at this two different ways. One, we will find particular solutions. Given a point. So we've looked at some examples of these. So remember that basically that point allows us to then solve for our C value. And we will also kind of go backwards. We will verify solutions, meaning that they will give us an equation and basically ask, does this solution make our original differential equation true? Or is it a particular solution? Now, the other thing that we're going to be looking at is what's called a slope field. And basically a slope field is a graphical representation of the slopes or solutions to a differential equation. So basically it's like a graph and we're going to draw a bunch of little lines on it that represent slopes at different points along our graph. And so it's just kind of a way for us to get a broad picture or broad idea of what the solutions to a specific differential equation are going to look like. So some key things that we want to remember are the solutions must be functions, which means to pass the vertical line test And we'll look at what that means here in a minute, okay? And in general, okay, we're going to draw these by picking points evaluating and generalizing. So some key things that we usually want to try and think about is where our slope is going to be 0, where our slope is going to be undefined, and where we will have a positive or a negative slope. So remember that when our slope is 0, our graph is going to have a horizontal line. When our slope is undefined, we have a vertical line. Where our slope is positive, we will be increasing, and where our slope is negative, we will be decreasing. So let's look at some examples. So this says to sketch the slope field for the following equation. dy dx equals 2x. So notice that the first thing we see here is that we do have a dy dx, which is what makes this a differential equation. All right. Now, for the most part, we have a pretty large grid here. You are not going to be asked to do a slope field this large. Okay, so we're just going to stick to the main points in the middle. Usually, you're going to be looking at like a 3x3, maybe a 4x4 that you would have to fill in. Okay, so usually a good place to start is going to be 0, 0, kind of in the center. All right, and then all we're doing is we're just plugging that in. So if I plug that in, notice that dy dx, or my slope, is going to be 2 times my x value. So we just get 0. So I'm going to come over to my point at 0, 0, and I'm going to draw a small little horizontal line. Now, so we said that our steps to this are going to be to pick a point, to plug in, get a value there, but then it's going to be to generalize. And what it means to generalize is we need to think to ourselves, okay, if I plugged in 0 for my x, I got out 0. But notice that I don't have a y here, so that means that anytime my x is 0, I'm going to get out a slope of 0, which is then going to tell us that all of our slopes along our y-axis are going to be horizontal lines. Okay, and the next point that we might try might be like say 1, 1. So again, my slope is going to be 2 times 1, which is just 2. So I'm going to come over to the point 1, 1, and I'm going to draw a slope of 2. Which would be something like that. Now, your grader, either me on our test or on the AP test, if they ask you to draw a slope field, they're not going to get super particular and be like, oh no, that looks like a 3 slope instead of a 2 slope, okay? But they are checking like, okay, is that have a positive slope and it's not a horizontal line. So it does need to be like generally correct. And notice that we can do the same thing here. Anytime that my x value is going to be 1, we're going to get out 2 for our slope. So I can kind of do the same thing we did before along the line. And say that all of those are going to be 2. Now let's use the same idea and think, okay, if I were to plug in a negative 1, I'm going to get a very similar answer. The only difference is it's now going to be negative 2. And that's going to be true for all of the points along that negative 1 line. And then our last step, we might think about, okay, as I get more positive, as my x values get bigger, notice that our slopes are going to get steeper because we're still multiplying by 2. So that just means that we're going to get steeper. Now, it's not quite a vertical line, but we're trying our best to draw it pretty steep. And then on the opposite side, it's going to be pretty steep as well. but just in the negative direction. Okay, so we have a slope field that would look something like this. Again, this is just to kind of give us an overall idea of what that slope might look like around our graph. Now, if we were asked to sketch through the point, let's say 0, -2, all they're asking us to do is to sketch the particular solution through that point. So I'm going to come to 0, -2, draw my point, okay? Notice that my slope is 0 here, which means that I have a minimum, and then we're getting larger on either side. So notice that we get a parabola-like shape, which makes sense because if I were to take the antiderivative of 2x, we would get x squared. Alright, continuing on, this time I have x plus y. So it's a little bit different because this time our slopes are going to be dependent upon x and y. So when we plug in points, we're going to have to look at what's happening there. So again, usually a good place to start is going to be 0, 0, okay? So we have dy dx equals, I would have 0 plus 0, which gives us 0. Now, we won't always get 0 at 0, but it is kind of common that when we do, we're going to get a horizontal line there. Now, again, we want to try and generalize that. So if we think, okay, this time if I plug in 0 for x, I'm not always going to get 0. However, if I plug in, say, a -1 and a +1, if my x and my y are opposites of each other, I will get 0 in that case. And so that means that if my x was -1, but my y was a +1, we would get 0. If my x was a -2 and my y was a 2, we would get 0, and so forth, going along that y equals -x line. The same thing is going to be true when my x is 1 and my y is -1, and so forth. So again, just trying to generalize, think about, what is going to give me 0, okay? On both of these last two, we have not had any spots where they have been undefined, but that's another good thing to think about. Are there any values that would give me stuff that is undefined? So then again, picking another point, let's say 1, 1. Notice here that we would get a slope of 2. We could plug in 0, 1, and we would get 1, and specifically because they give us -1, 0, that would also be a good one to plug in. That slope is going to be -1. So coming back to my graph, we got that 1, 1 is 2. Thinking about 1, 0, we would get 1. 0, 1, we also get 1. -1, 0, we get -1. 0, -1, we also get -1. review thing or something?
I was going to tonight.
If you have it, I could have covered for your math teacher yesterday. I picked a different teacher.
No, you wouldn't.
Well, one in the same hour. I would have been in their third hour, but I don't know what third hour.
Third hour is history.
I don't walk that far.
It's all the way in Seahawks.
Okay.
Love you.
Have fun.
You have $1.
Do not.
Okay. That's why I'm gonna get popcorn.
What do you want?
Okay. Love you.
Love you.
Oh. Tomorrow, can you maybe bring my book that I got for Christmas? Like it's behind like my little cardboard wall, and it's the only one in like a stack of one.
Okay.
It has like a horse and a house on front. The war I finally won.
Okay.
Do you have the permission slips for tomorrow?
I don't have any more right now. They're at the front of the cafeteria. There's like a booth set up that has like stacks of them.
Okay, thank you.
Alright, so again, let's continue on and just fill in a couple more values. So when I'm in my fourth quadrant, notice that my x values are going to be positive, but my y values are going to be negative. So we will usually get a negative value. And the farther that we come negative, the steeper that we're going to get. And similarly, going the opposite direction, it's just going to get more and more steep going the positive direction. So now, again, they ask us to draw a point through -1, 0. So we're just going to sketch our point. And then just kind of follow our slopes. So we look something like that. Again, not looking for a perfect drawing, mostly just is it going through the correct points, and are we following the path that we're supposed to be following? Alright, so here, this time we do have a fraction. So notice that a couple of key things that we would probably want to take away is 1, okay? Notice that if my x value equals 0, then our slope is also going to equal 0. However, if our y value equals 0, then our slope is going to be undefined. So those are going to be two big takeaways. So remember that slope being 0 is a horizontal line, slope being undefined is a vertical line. Again, notice that if both x and y are positive, the slope is going to be positive. If both x and y are negative, my slope is still going to be positive. But on the flip side, if x or y is negative, but not the other, then I'm going to have a negative slope, which means that in my first and my third quadrant, we're going to have positive slopes, but in my second and fourth, we're going to have negative slopes. So we would end up with something kind of like this. So notice that along my y-axis, we have horizontal lines. Along my x-axis, we have vertical lines. And again, we're positive in our first and fourth, negative in our second third. And the big key here is notice that at 0, 0, we do not have a slope because we would get 0 over 0, which is an indeterminate form. So if you get something that is an indeterminate form, you just do not put a slope at that spot. Okay? And something to consider is if we were going to go through, they said, -0, -2. We would draw a point there, and again,